Welcome back. We're continuing our series on friction loss for fire sprinkler systems in this segment. Now that we've covered what friction and friction loss are in this segment, we're going to answer the question, why does friction loss really matter? In short, our system of hydraulic calculations has a system demand and a system supply. The system demand will lead to two critical numbers: what flow we need, presented to the hazard we're trying to predict, and at what pressure we need that flow to be delivered. We have to compare that demand for the system, both the flow and the pressure, with what is available in our water supply. Is the demand less than the water supply? Well, great. Our system is adequately designed. If the demand is more than the supply, well, if we need more pressure to make it work, we could add a pump, for instance, and that would increase the available pressure and meet the demand. What if we're short on flow and our demand has a flow that is greater than what the supply can produce? Well, then we're likely going to need a source of water to supplement the flow. A water storage tank can come into play here, which would, again, allow the demand to be less than the available supply. Just keep in mind that storage tanks often need supplemental pressure, a pump, to meet the demand pressure. What if we don't have either pressure or enough flow? Well, then we could be looking at a pump and a tank in order to meet our demand. In a nutshell, that's what we're doing when we conduct hydraulic calculations. Friction loss is a big part of those calculations. To understand how much water we have at the demand area, or the hydraulically most demanding area, which is all the way down the downstream side, and how that translates back to the water supply, we have to know how the water behaves between the supply and the demand as it moves through the pipes. That's where friction loss plays a key role. In our recent series on hydraulics and hydrokinetics, we looked at the relationship between elevation and pressure, and then the behavior for fluids when they are in motion. Well, the major component of how pressure changes through the complex system is friction loss. We need to be able to understand friction loss as water moves through the system so that we can do our comparison with the demand side relative to the supply that is required. Here's an example. The most demanding sprinkler must operate at greater than or equal to 7 psi. Some sprinklers, like extended coverage or storage sprinklers, may need far more than 7 psi to operate. But let's say we have a basic wet pipe tree-type system, and the most demanding sprinkler needs simply 7 psi to operate. We would need to calculate the friction loss from that sprinkler to the next sprinkler upstream, and so forth through the entire pipe system. We would need to add the flow to the second sprinkler to get the total flow, and then work again upstream, again and again, sprinkler to sprinkler. Each time we move upstream, we're going to encounter friction loss. We might have started at 7 psi, but when we reach the second sprinkler, maybe we need 8 psi at this point to make the system work. To make the system work in this case means that we're going to deliver water to the first sprinkler as well as the second sprinkler. And then when we reach the third sprinkler, maybe we need 10 psi at this point to make the system work. We'd be adding flow and work upstream on and on and on until we get to the cross main, the feed mains, and then we calculate the loss back to the riser, and then work all the way upstream to the source exterior to the building. For example, the fire hydrant where we got our original flow test data. Each step along the way involves friction loss. And that's why this is so important for us to understand what is happening in the system hydraulically. Our entire comparison depends on that understanding. So why is friction loss so important? It's important because it's the link between what happens at the system demand and how that translates all the way back to the point of our system supply. This is Ed Henderson. This is MeyerFire University.
This has been a preview of MeyerFire University. Join the next generation of fire protection experts at www.meyerfireuniversity.com.